Welcome to this Python crash course, where we're going to be showing you how to go from absolute novice, beginner, zero coding experience to being able to understand and write basic Python. Now, Python is one of the top development languages to learn on the planet, especially because in the wave of AI, so many AI tools are written in Python. And additionally, AI tools understand Python really well so that when you run into bugs, AIs can help you debug them very quickly. Python developers are going to get more and more in demand as AI becomes more and more prevalent. And additionally, people with really, really strong Python skills are going to become more in demand because when AI can't help you with your code, you're going to need a very knowledgeable person to fill in the gaps where AI cannot. And that takes a lot of knowledge and a lot of expertise. But with just a little bit of Python knowledge, you can start applying for jobs that pay over $100,000 a year, and additionally do things like automate payments, automate your calendar, interact with smart contracts, and so much more. We're going to awaken the developer inside you, awaken the engineer inside you in this crash course. By the end of this, you will have a basic understanding of Python, and we'll even give you the different directions you can go next to keep going, go further with your developer career. Now, in this Python crash course, we're going to do three things for you. Number one, we're going to go to Google Collab and teach you some basics of Python. Now, Google Collab is great because it's already got Python installed. Everything is set up for you. All you have to do is show up and click the little play button that we're going to show you. And you're going to learn the basics of Python. Then number two, we're going to move away from Google Collab, which is on a website, into your local machine so that you can run Python on your own local machine. And that is the difference of a kind of new beginner Python developer and someone who's really ready to take the power of Python and put it to good use. Now, we're going to teach you how to install Python two ways. Number one, the way that a lot of other tutorials are going to teach you how to do it. And then number two, the better way, well, we think it's the better way, that we think you should install Python because it's going to make working with Python a lot easier. Now, I will say this, installing Python is probably the hardest part of Python. So there's a couple ways to watch this crash course. Number one, you can finish Google Colab and you can say, hey, you know what, I'm done. I don't really care about this. And then number two, you go the extra mile and you try to get Python installed and you try to get Python working. But if you run into issues, there are tons of resources to get you set up. So when you get to installing Python, sit down, maybe grab some popcorn and just say, hey, I'm here for the experience of installing Python. And if you get stuck, you can ask the GitHub discussions, link in the description below. You can ask an AI buddy like Claude v3.5, ChatGPT, etc. Or you can do the old school way of Googling around for answers to your solution. But I will say this, don't give up. You can do it. It's going to be hard, but that's okay. Now, this Python crash course is actually an excerpt from a much longer course, which teaches you Python development in the blockchain, in the smart contract development space. So one of those paths, if you'd like to take, if you want to go from Python developer to blockchain developer, you can head on over to Cyfrin Updraft and take the brand new Python and Viper course, or path, which will not only teach you more advanced ways to work with Python, but also advanced ways to work with Viper, a smart contract development language that is very, very similar to Python, which makes it easy to kind of learn both of them at the same time. So throughout this, there might be references to Viper, but if you haven't done any of the Viper stuff, don't worry, just ignore it when I say that. Now, additionally, very quickly, I'm posting this on my YouTube channel where I have been silent for a few months now, because honestly, I've been busy working on this course. In that time, we hit over 100,000 subscribers, and I want to give a huge, huge thank you to everybody watching. And as such, in all of the next videos throughout the month of December, I will hide little codes like this in videos, which will lead you to a smart contract where if you input that code, you will win between $50 and $100. And if you don't know how to work with smart contracts, well, then you should head over to Cyfrin Updraft so you can learn how to work with smart contracts so you can win that $50, which also means you should subscribe and be sure to watch every single video to look for those codes throughout the month of December. We have over $1,500 in prizes available on these contracts on the ZKSync network. So be sure to learn smart contract development so that you can see these codes and then go win the money. So with all that being said, let's jump in. Let's start learning some Python. Let's awaken that engineer inside of you so you can be a force for good in the coming age of AI and technology. Let's start teaching you Python fundamentals. I am going to give you a crash course, and we are going to give you a crash course in Python here, and we're going to do it a lot differently than a lot of the tutorials out there. The way we're going to do it is we're first going to walk you through coding in Python with this tool called Google Colab. Now, the reason we're going to start with this is because you don't have to do any downloading or any installations or anything like that. It's very similar to Remix, how we were able to do everything online and in the browser. With Google Collab, we can actually do the same thing. We can do everything online and in the browser window here without having to fiddle with our local setup. And the completed code for this Google Collab will be located here, and we'll do a brief walkthrough of everything that you're going to see. Once we do this crash course, once we walk through this Python crash course, and again, hint, hint, because you actually walked through both of these, I secretly was teaching you Python the whole time. This Python crash course is going to be a breeze for you. Once you finish going through this Google Collab, then we'll walk through getting you set up on macOS and Linux and getting you set up on Windows with WSL. Microsoft will tell you to set up your development environment using Python from the Windows Store, using PowerShell, using all this stuff. And I'm going to tell you right now, we're not going to do that. I don't want you doing that. That's not how professionals do this. We're going to teach you the Linux-based way, which is how maybe 90% of all developers work, probably 99% of smart contract developers, maybe 90% of not smart contract developers. But we're not going to follow this PowerShell, this Microsoft way. We're going to do it the Updraft, the Web3 way. So first, we're going to go over Google Collab and do a Python crash course. Then we're going to go up installation and setup based off of your local environment. And then we're going to do this Python in Updraft section. Now, if you are pretty good at Python, if you've got a good foundation, if you've got a good grasp of Python already, skip all of this, but don't skip the Python in Updraft section. I promise you there is a pretty good chance that the Python in Updraft section will be different from what you're used to. So wanted to give you this heads up that this is the steps we're going to take. We're first going to walk through a Python crash course with Google Collab. Then we're going to learn how to actually install and set up Python on your computers. And in my opinion, this is actually the hardest part of this whole course, is getting Python set up locally. Let's get started with the Python crash course. Yes, you're learning smart contract development, but we're also teaching you Python. If you're brand new to coding, we're doing double duty here. You're learning Python and you're learning smart contract development. So let's go ahead. Let's get started with Google Collab. So if you're following along with the course now, let's scroll on down to where are we at? We're going to our Moccasin fundamentals, starting with section 1, the Python crash course. And we're going to be using this tool called Google Collab. It's a online browser IDE for typing and working with Python. And you can see kind of all the different code that's in here. This is the final code. And if you get lost or you get confused, click this link and you'll be able to see the code in here. So to get started, let's go ahead and click this link here, which will open up us into Google Collab, which, like we said, is kind of like an online Pythonic IDE. This will be the final Google Collab here. However, we don't want to use the final one. We're going to start from a brand new one. So what you can do, now you will need a Google account to use this. So if you prefer to not use a Google account, if you don't want to use Google Collab, and you're familiar with other Python notebook tooling, feel free to do so. But to use this, you will need a Google account. So this is going to be all the completed code, but we don't want to use the completed code here. We want to do a new notebook so that you can practice getting these done yourself. So we're going to select File, New Notebook in Drive, which will open us up in a new notebook here. So let's go ahead and name this Updraft Python or whatever you want to name it. And let's go ahead and get started with this Python crash course. These are known as Jupyter, formerly IPython notebooks, and it's an open source project that allows you to easily combine markup text, Python executables, and more into this thing called a notebook. In this notebook, you have all these different cells where you can run little snippets of Python. So it's in these little sections here is where we can add our code. If I wanted my program to just print hello, I could say print hi, and then go to runtime and hit run selection, and it will run this shell, this little line here. You can see at the bottom, it has to do a little bit of setup first, and then we get printed out here, hi. You can see there's a lot of keyboard shortcuts as well to do a lot of what we're going to be doing here. I did run selection, which was this set of keyboard shortcuts here. So I can also just do the keyboard shortcut, and that will also run the cell. Now, when I hit runtime run selection, I'm actually just running that
single line that my cursor is on. So if I have several lines like print hi and down here print by, if I have my cursor on the print hi and I do runtime run selection, I'll just run. After a brief delay, I only get printed out hi. However, we could also press this play button here, and this will run everything inside this little box, which is known as the cell. If I hit the play button here, we now see hi and by. If I put my cursor directly on this line and I do runtime run selection, I will only print out by. Now, for most of these, the easiest way to run the whole cell is just to click this button like here. You can also run the whole cell with keyboard shortcuts like Shift Enter, which will run the whole shell and also create a shell down here. You can hit Command Enter, which will also run the whole shell, or Control Enter. And there's a lot of other keyboard shortcuts that you can run as well. If I wanted my command to print something else out, I could print something like by, run the cell again, and we would get by gets printed out. Now we can additionally have comments. Hi, I'm a comment. Anything that's prefixed with this little hashtag here means anything after it is going to be a comment. So this too would be like another comment. And comments are parts of the code that will not be executed. Let's change this back to hi and run again. And our code prints out hi. What's really nice about Google Colab is that if you don't understand something, you can use the AI features such as Google Gemini. I'm going to go ahead and hit Gemini here. Be sure to read the privacy notice. Let's continue. And you can enter different prompts here. We could even copy all the code here. If we don't understand what's going on, go into Gemini and write our little prompt. What does this code do? 3 backticks, another new line with Shift Enter, paste it in, Shift Enter again, 3 more backticks. This is typically how you notate that something is code. You put 3 backticks, put all the code, and 3 more backticks. So what does this code do? Let me zoom out a little bit. We'll hit Enter. Gemini will start thinking. Okay, let's break this down. This line is a comment. Comments in Python start with the hashtag symbol. They are ignored in Python interpreter and are intended for humans to read. This comment is simply saying, hi, I'm a comment. Print hi. This line is a function called to the built-in print function. This function takes 1 or more arguments and displays them in the console. In this case, it is printing the string hi to the console. And then another comment and blah, blah, blah. It even gives you some sources for where it learned how to understand what this is doing. It did a little bit of Googling itself on the back end. So as you're coding, as you're learning, feel free to use different AI features to help expedite your learning process here. And then we can hit these 3 dots, close tab to close the tab here. Okay, great. Let's keep this here. And then if you want to save this locally for later, you can hit File, Download, and then you can download this as a .pynb or .py file for you to have it locally if you want to study offline as well. But let's go ahead, let's create a new cell or a new block of code by scrolling down, and we'll see this plus code button here, and we'll click that and we'll get a new cell. If you want to practice using some generative stuff, you can, if you want to practice using some generative code, you can click generate here, and you could type something as simple as write a print statement to print out the word hi, hit enter, and it'll give you exactly kind of the code that you want here. It's important though that you do understand what this code is actually doing so that when AI gets it wrong, you can actually correct it. But let's go ahead, we'll close this and we'll delete everything in here and start with the next section. So let's talk about variables. In Python, you can assign different variables, and my generative AI is even giving me a suggestion here. And variables are essentially just keywords that we can use to represent some other value. For example, I can say my variable equals 7. Now, anytime I use this keyword, my variable, it's going to represent the number 7. So if I were to print out my variable, what do you think it would print out? Well, if we hit this little play button here to execute the cell, we see it prints out the number 7 because my variable now represents 7. The keywords or the names of your variables can be almost anything that you want. You can assign almost anything to a variable, and Python comes with many types. For example, we can assign numbers. My number equals 10. You can assign something called booleans, which are true or false. You can say my boolean equals true. We could also do false. You can assign whole strings or text. My string equals hello. Strings are notated by being between these little quotes here. You can use single quotes or double quotes. Both work great in Python. If the word string is a little confusing to you, just know that anytime someone says, hey, this is a string just means it's text. It means it's not a number, it's not a Boolean, it's just text. Additionally, in Python, we can use something called type hints, where we could say my typed number. We would then put a little colon and say int equals 9, or whatever number we wanted to put here. This little colon and then int is known as a type hint. And it's more helpful for human beings to know that, hey, anytime you see my typed number, that's going to be an integer or a number. We could also say my typed bool, which is of type bool, equals false. We could say my typed string, which will be of type str or string, equals hi. So str is a type hint for string. Bool is a type hint for a Boolean, which is a true false. Int is a type hint for an integer, aka a number. You can also update variables. So my variable originally started off as 7. We can copy this value, paste it here, and then we can update it to 77. So you can have all these really cool variables, and there are even more complicated variables that you can have. So let's create a new section, a new cell here, and let's create a list. So, or an array. So let's say my list equals 7 cat true. Your lists can be of just about anything, and you can even type into your variable my list by saying my list is of type list. These little brackets notate that this is the list. And these are the different elements or objects inside of the list. So 7, cat, and true are in the list. We can also print my list, same as we print any other variable. And if we hit the play button here, we see 7, cat, true. Now, each one of these objects in a list has a certain index. So 7 is the first item in the list. Cat is the next item in the list, or the second item in the list. And then true is the third item in the list. However, in Python and in most programming languages, the first index is actually the 0th index. So 7 is actually at position 0. Cat is at position 1, and true is at position 2. This can be a little confusing at first, but after you use it for a while, it becomes second nature. Now that we know each one of these elements or these items in our list have a different index, we can actually update specific indexes. So I could say my list at index 1, and we use these bracket notations to do so, equals dog, or is set to dog. The way to read this equal sign is set to. So we're saying my variable is set to 7. My list of 1 is set to dog. Now, if we were to print out my list again and run and execute the cell, we now see 7 cat true and then 7 cat dog because we updated the element at index 1, which previously was cat. We updated cat to dog. Python also has some incredible features to help sort lists and make them much easier to work with. So if we had a list of numbers, my numbered list equals 0, 7, 8, 2, 3, or 3, 99. This list is pretty out of order. So what we can do, and if we were to print it right now, print my numbered list, let's go ahead and execute the cell. We see it's still out of order. What we could do is we could call my numbered list dot sort and then print it out again, execute the cell, and we would see it's now in the correct order. This dot sort is known as a method or a function of the list. So let's scroll down, let's create a new code section, and let's talk about input. So we can additionally have our code prompt users for information. So I could say input, what is your name? And then execute the cell. And we see Python is actually going to prompt us saying, what is your name? If I type anything in here right now, nothing happens. It just says, I just said, my name is Patrick. And it said, oh, okay, cool. My name is Patrick. So what we could do is we could save whatever input the user has to a variable. So if I say name equals input, what is your name? And then print out my name is plus, name. This plus operator here is a way for one string to be concatenated with another string. So if I go ahead and I hit play here and I type in Patrick, what do you think it'll print out? My name is Patrick. My name is plus whatever the input was given us, plus name, which is going to represent whatever we set for the input. Another way to represent this kind of string with concatenation is using something called an F string. So I could also say print F, and then our quotes here, curly brackets, name is my name. So if you have an F string, if you prefix your quotes with the character F, and then in curly brackets, you have some variable, it'll input the variable inside of those curly brackets. So now if we execute this cell, and I say my name is Patrick, it's going to say my name is Patrick, and Patrick is my name. Now I can create a new code block, and let's talk about types. You can convert types from one to another using something called casting. For example, let's say I had this year equals 2025. Now, since this has quotes around it, this is technically a string. This is a string. If I got rid of the quotes, it would be a number. It would be an int. But since it has quotes, it's a string. Now, what if we tried to add 25 to this year number here? Well, let's go ahead and try it out. Let's say year plus 25, and we'll execute the cell. We actually get an error. Can only concatenate string, not int to string. Since 25 is an int and year is a string, right? Because year plus 25 is essentially doing 2025 as a string plus 25. Python goes, hey, you can't actually do that. So what we can do is, since 2025 is clearly a number, we can typecast it to being an int. So we'll say year as int equals int year. And now we can do year as int plus 25, execute the cell, and we see 2050 here. You'll notice that I didn't put a print line here. That's because in these Python cells, whatever the last line is will get printed, but it's probably better to just wrap this up as a print or to copy this to a new variable called added up year equals year is int plus 25, and then print the variable here. And let's execute that cell, and we get 2050 again. We can also convert this number back into a string. So we could say year string equals str, open and closed parenthesis, and then do a little print. Year string plus is 25 years after 2025. Execute this line, and we'll now see 2050, and we see the print line that we just added. 2050 is 25 years after 2025. Let's do a little bit of math. You can do math in Python. So let's start with simple adds here. My number equals 5 plus 5. Print my underscore number. The little plus button here. Add 10. 5 plus 5 is 10. Good job, Python. Print subtract my number equals 5 minus 5. Print my number. That should be 0. Let's go ahead and try that out. Great. Subtract gives us 0. Let's do print multiply my number equals 5 times 5. Print my number. We'll do print divide my number equals 7 divided by 2. Print my number. And let's hit the execute button, and I'll zoom out a little bit here. Add 5 plus 5 is 10. Subtract 5 minus 5 is 0. Multiply, great. 5 times 5 is 25. Great. Divide. 7 divided by 2 is 3.5. Awesome. Now, there are even more advanced types of math that we can do. For example, we can do something called integer division. So we'll do a little print integer division. To do some integer division, we could say my number equals 7 divide 2. Print my number. Integer division will always round down your division to the nearest whole number, and it will get rid of any decimals. So 7 divided by 2 is 3.5, but 7 integer division by 2 is what? Well, let's press play. We can see 7 divided by 2 with integer division will just be 3. We can also do something called modulo. This is where you'll get the remainder of division. So we could say my number equals 7% 2. This percent stands for modulo, and then print my number. What do you think this will give us? Let's hit the play button. Returns 1, because 7 divided by 2 gives us 3 even divisions, and then we have 1 left over. So divided by 2, we get 2 plus 2 plus 2. So there's 3 2's, and then we have this additional plus 1. This 1 is the remainder in our division. So that's how we get the modulo of 1. Another example would be, what's 6 modulo 2? Well, 6 is evenly divisible by 2. So this will give us what? If we hit play, gives us 0, because 6 divides perfectly into 2. If we do 6 divided by 4, what do you think we'll get? We'll hit play. We get 2, because 6 divided by 4 is 1.5, and that 0.5 represents the 2 remaining. So let's put this back to 7 modulo 2, and that's how the modulo works. We can also do things like exponents, which are represented by my number equals 2 double multiply 3. This double multiply means raised to the power of 3, and then we can print my number, hit play, and we'll see exponents is 8. 2 raised to the power of 3 is 8. All right, let's create a new section now. And now let's start talking about functions. Functions can be written by typing out the def keyword. A function is a self-contained reusable chunk of logic. Now, this is especially where AI is going to be helpful, because functions can be very tricky and difficult to understand. But let's say we wanted to create a function that will print hi 2 times for us. So we can create a function by having the def keyword, and then we'll give our function a name, print hi 2 times, open and close parenthesis, and then a colon here. We'll explain what this parentheses bit do in just a minute. Then we'll hit enter, and you'll see that Google Colab will even indent your function a little bit here. So the line doesn't start over here, it actually starts up here, tabbed in. This is because when it comes to functions, Python is a indentation-based language where you need to indent to type the body of the function. So this is the function name, print hi 2 times, and anything that's indented will be considered part of this function. So if I print the keyword hi, and then in a new line, I print the keyword hi, since hi here is indented, this print line of hi is considered part of this function, but Python will see that this is not indented and say, oh, well, this line isn't part of the function. So if I indent it though, now both lines are part of print hi 2 times, and we have 2 hi print statements. If I run this cell right now, nothing will happen. We don't see any hi's printed out. But if I copy print high 2 times, and I'm doing that with a little bit of shortcut of double clicking print high 2 times and then hitting Command C or Control C. And if I paste out print high 2 times and add those parentheses, and then I run the cell, it's going to print high out 2 times. This is because this is considered an invocation or a calling of our print 2 times function. Up here where we have def print 2 times, this is just where we defined, hey, anytime somebody calls print 2 times, these are the things that they should do. They should do print high and then print high. But you should only do these things when somebody calls this function. And this line down here where it says print 2 times with the open and closed bracket, that's an example of somebody calling that method or calling that function. So this is why you see it print out high after we added this line here, because before we had this line here, nobody was calling this function. So now, anytime I want to print high 2 times, instead of having to write this print high twice, we can just put this function. I could even do it again, and I'll hit play, and now it'll do high. Functions are incredibly useful for when you have very complex or chunks of logic that you want to reuse, and because this is much easier to write often than writing all the code inside of a function. Now, you can also create functions where you pass parameters to them. For example, if I were to say def print some word and pass in my word, print my word, like this, we now have a function that takes some word as parameter and it's going to print it out. So now I could call print my word or print some word, miss you mom, and we'll run this and we'll see it prints out miss you mom. Because print some word is called with this as an input parameter, miss you mom gets assigned to my word, and then we print out my word. So you can almost think about when we call this line, miss you mom is placed into here, and print my word is placed into here. We can also do more interesting things with math. We could say def add 6, my number. And we could just do print my number plus 6. So now we have a function that takes some number as an input parameter, adds 6 to it, and then prints it. So if I were to now call add 6 of 10, it should print out 16. Let's hit play, and we see it does indeed print out 16. You can also have functions that take more than one parameter. So I could do like def add together my first number, comma, my second number, and just say print my first number plus my second number, like this. And I could just call add together, comma, 20, and it will add 10 and 20 together and then print out the result. So if I hit play here, scroll all the way to the bottom, 10 plus 20 is 30. Python, you can also have this concept of what's called conditionals. So let's create a new cell or a new chunk of code. And in here, we can do if/else statements, which are known as conditionals. I could say if 7 is greater than 5, print 7 is greater than 5. And I could run this code right as it is here, and we'll see 7 is greater than 5 is indeed printed out. If I wanted to see if these were equal, I could say if 7 double equals 5, print 7 is greater than 5. And if I were to run this cell, it does not print anything out because 7 is not equals to 5. You'll notice I'm using a double equals here and not a single equals here, because technically this single equals is saying set to. So if I'm saying if 7 is set to 5, which doesn't really make sense. So if I want to check if they're actually equal, I'll say if 7 is equal to 5. And again, if we print this out, nothing gets printed because 7 is not equal to 5. You'll notice, just like functions, we have some indentation here. If I remove this indentation, Python actually gives us an error and saying it expected an indentation block after an if statement. So we'll go back, we'll indent it, we'll run it. It doesn't print out. But if we say if 7 is greater than 5, we print it, it'll say 7 is greater than 5. We can also do an else statement with this colon here. We'll hit enter, print 5 is greater than 7. So if we run this line again, we still get printed out 7 is greater than 5, because what we're saying is if 7 is greater than 5, print out 7 is greater than 5, else print out 5 is greater than 7. If we were to flip the sign around to say if 7 is less than 5, print 7 is greater than 5. Now, since 7 is actually not less than 5, it's greater than 5, it won't execute this line. It'll go to this else statement and execute this line. So now if we hit play, we see 5 is greater than 7. This is kind of similar to saying if true, do this. If otherwise, do this. So we can even run this and we say 7 is greater than 5. If true, print this. If false, don't do this, do the else. And if that's a little confusing, don't worry about it for now. It'll make sense to you the more you do this. All right, let's keep going. Let's scroll down. Let's create a new coding section, and let's start our section on loops. So let's say we wanted to print out the word hi 1,000 times. It would be incredibly tedious to write hi 1,000 times. Is there a better way? And well, there sure is. In Python, we can do repetitive tasks with something called loops. And there are many different types of loops that we can use. The first one is going to be the while loop. So let's say we have a variable called myNumber that starts at 0. So myNumber is set to 0. We can then do something like while myNumber is less than 3. We do the little colon here, press enter, and you'll notice once again, we're indented to know that we're inside of this while loop. We could say print my number is plus str my number. And as long as my number stays less than 3, Python will just keep looping and running this. Now, don't hit the play button yet, because Python would technically run into an infinite loop, because my number would always be less than 3, since my number is never incremented. So first we'll say print my number is plus my number, and then we'll say my number equals my number plus 1. And this is how every single time we run this loop, we add 1 to the number here, and then we'll print out done. Notice again that this print done is outside of the while loop because it's not indented. So if we hit play here, we scroll down, you'll see we get my number is 0, my number is 1, my number is 2, and then done. You see it stops because once my number is set to 3, my number is no longer strictly less than 3, and it will execute. So we can even kind of visualize this a little better by saying, okay, my number starts off as 0. Then we enter the loop. My number is 0, so it says while 0 is less than 3, 0 is less than 3, so it goes into the loop. Print out my number is, again, it's 0, so it would print out 0. And then my number equals 0 plus 1, so then my number would be set to 1. So while 1 is less than 3, print my number is 1, and then my number equals 1 plus 1, which is now 2. So then my number is then set to 2. And we would read it as while 2 is less than 3, which it is. We would print out my number is 2. My number equals 2 plus 1. So my number now equals 3. Then we would hit while 3 is less than 3. Now 3 is not less than 3. 3 is equal to 3. So it will skip executing the loop and just print out the done. So that's how you can think of walking through these while loops here. And let's just revert everything back and we'll hit play and boom. Now there's several different types of loops in Python. The next one is going to be the for range loop. And this one's a little bit more concise than this while loop that we did up here. So instead we could say for each number in range 3, print my number is plus str my number, and then print done. This for range loop says for every single number in the range of 3, print out my number is my number. If we hit play, we'll see, whoops, I have my number here, and this should be number instead of my number because we want it to be this in range 3. Let's go ahead and hit play again. We now see my number is 0, 1, 2. So in range 3 says from 0 to 2, which is going to be 0, 1, and 2, print out my number is plus the number. So we get 0, 1, 2. This is a much more concise way of doing what we did above here with this while loop for number in range. And then finally, let's look at the for each loop. So let's say we have a list. My list equals 0, 1, 2. We could loop through all the elements in this list by saying for each element or each item in my list, print my number is plus str element, then print done. So it's going to loop through every single element in here, and the element will be one of the elements in here. So if we hit play for this one, we scroll down, we see my number is 0, my number is 1, my number is 2. If we were to add maybe 3, 4, or 3, 5, 7, and then hit play, scroll down, we see the 3, 5, and 7 added to the print statements here. You can see how using these loops would be a really easy way to print out high 1,000 times. We could do something as simple as for number in range 1,000, print this. Now, I recommend you don't do this because you're going to get a massive cell that gets outputted here. You know what? Screw it. Let's try it. For number in range 1,000, let's go ahead and hit play. If we scroll down, we see just a ton of numbers. Some of this was even truncated, and we'd have to scroll for a long time, but you can see it's printing out every single number between 0 and 999. So let's leave this as 3, so it's a lot more digestible. And let's continue on with what we're learning. All right, now it's time for your final workshop project of this crash course, this what year function workshop. Here's what we want you to do to practice everything that you've learned. And you can use AI to help you. But what I don't want you to do is just copy paste this whole question into AI. I want you to try to do it without copy pasting the prompt. You can still ask Gemini something like, what is a variable in Python, and stuff like that. But try to use AI as little as possible and use the information you have up here as much as possible. What I want you to do is create a function that takes 2 inputs. The first is a year, and the second is number of days. And the function should either print out Y days after January 1st, X, it will still be the year X, or Y days after January 1st, X, it will be the year Z. Where X is the starting year, the first input to the function, Y is the number of days, the second input to the function, and Z is the year after X number of days. For example, if you were to do what year, 1985, 376, it should print 376 days after January 1st, 1985 would be the year 1986, because there are 365 days in the year. This is more than 365 days. It's going to be 1 year later. But if you did something with less than 365 days, it should print out 200 days after January 1st, 1985. It will still be the year 1985. Or if you were to do something like what year, 1985, 1098, it should print 1098 days after January 1st, 1985, it will be the year 1988. Notice how still is only added in this sentence when the year is 1985, even after the days are added. Here's some assumptions. Assume a year is 365 days, and if you're off by a day or two, that's okay. It doesn't have to be perfect. Don't worry about leap years. Don't use the datetime package. Just assume a year is 365 days to make it very simple. Let me show you some examples of what it should look like when you're done. And again, In the GitHub repo associated with this course, the final solution will be available in this completed code so that you can reference what I did to what you did. But for example, you should be able to do what year 2000 and add 366 days, execute the cell, and it'll print out 366 days after January 1st, 2000, it will be the year 2001. Or if I were to do 50 in here, hit play, 50 days after January 1st, 2000, it will still be the year 2000. So this is what you should be able to do at the end of this. So go ahead, pause the course, and let's see what you can do creating this what year function. All right, so spoilers in here. Ahead of me is what I have as the sample solution to this. We created our function that took two parameters, a start year and days. To calculate how many years had passed, we decided to use integer division because it rounded down to figure out exactly how many years had passed. To get that amount, we did the number of days sent in, integer divisioned by 365, and to get the target year, the number of years later, we just did the start year, which was the first parameter, plus years passed. Then we did a conditional where if years passed was greater than 0, we said print days after, well, we said days after January 1st, start year, it would be the year, target year. Otherwise, if years passed was still 0, we would say print days after January 1st, it will still be the year, target year. And this allowed us to do all of the examples from our prompt. And if we ran this here, we would see 376 days after January 1st, 1985, it will be the year 1986. 200 days after January 1st, 1985, it will still be the year 1985. 1,098 days after January 1st, 1985, it will be the year 1988. And this was your crash course in Python using Google Colab. Now, a lot of people, both data scientists and portfolio managers or people who work at hedge funds or asset managers, they use things like these Python notebooks or Google Colab in their professional work environment. Now, there was a lot in this course, and if you took the workshop, if you were able to come up with this function, if you were able to come up with a solution here, give yourself a massive round of applause and maybe get yourself some ice cream and then go to the gym, because you should be incredibly proud of yourself for getting this far. It took me a long time to learn how to code Python, and learning a lot of the basics here is absolutely fantastic. Now, there's a lot more for us to learn. Coding on Google Colab or Remix or any online IDE is great. However, we can write way more production professional code in our own local environments. So now it's a great time for you to take a break, go get a coffee, go for a walk, go to the gym, and I'll see you soon. Because what we're going to do next is, in my opinion, the hardest part of any Python tutorial. And honestly, I feel like this is the part of Python tutorials that most educators gloss over the most. Because setting up your Python environment on your local computer can be incredibly challenging. So we're going to spend the time to make sure we get you set up correct so that you can be successful. Now, I do actually want you to take at least a 30-minute break before going to this next section, because I want some of the information here to settle in. And guess what? Your brain cannot process too much information in a day. It will do a worse job of learning that information. So pause for at least a half an hour. If you've already been coding for a while today, pause for the whole day, because installing Python and getting your environment set up correctly can take a long time. And if it does take a long time, don't be frustrated. It took me a long time the first time I got it set up, but if you can get through installing Python and installing your environment the correct way, you can do anything, because it's honestly the hardest part of all of this. So take a break and I'll see you soon. Now, for the rest of this course and the rest of this tutorial, I'm going to be working with this thing called Visual Studio Code. You might also hear it referred to as VS Code, but it's Visual Studio Code. And this is essentially what it looks like. And this is the website for it. And it's important to know that Visual Studio Code is very different from Visual Studio or Visual Studio IDE. I know they all have almost the exact same name. I know they look very similar, but they're totally different. Visual Studio Code is what we want to work with. not Visual Studio. You can see the logos are also kind of similar. I don't know who decided to do that from their end, but I digress. Now, if you choose so and you're a total hardo, you can do everything in this course in a raw terminal. That works great. And I know a lot of people like to use something like a Google Colab. However, for this, I'm going to recommend you don't work with a notebook because for developing our smart contracts, the notebooks are much less reproducible and are phenomenal for kind of testing and tinkering, but not as great for building production environments. And I want to teach you how to be a professional. And of course, if you're working with Atom or Sublime or some other code editor, you can absolutely do so. In the next couple of sections, I'm going to go through setting up VS Code the way that I like it set up. However, you can, of course, set it up however you like. But the reason I'm going to show you the way that I'm going to set it up is because I think it's going to make your development experience a lot easier. And I'm going to show you a lot of the pitfalls if you set it up wrong. And additionally, we'll work with AI to debug any issues that we run into. Now, to get set up, we're actually going to go through 3 different installation processes. The first one is going to be for Mac OS and Linux environments. Most professionals in both blockchain and pretty much any other industry in the world works on a Linux-like environment. Mac OS by default is Linux-like. Windows users have a very different environment, and so we're actually going to teach you how to download and install things in a very different way. And then finally, I'll show you the GitHub code spaces or the Git pod setup. However, I highly recommend you don't use Gitpod or code spaces as you can very quickly run out of your free trial of those applications. And this is blockchain. You don't really want to be sharing your secrets or your private keys with those anyways. So we're going to go through 3 ways of setting this up. Linux/Mac OS, number 1, Windows, number 2, and then Gitpod/codebase, and then Gitpod/code spaces for number 3. However, I recommend you don't do number 3. The first thing you're going to want to do is download the Mac, or if you're working with Linux, download the Linux installation of Visual Studio Code. Once you have it installed, it'll look a little something like this. And if it's a fresh installation, it'll even give you some tips and tools to actually get started. If you've never worked with Visual Studio Code before, I highly recommend going through any get started or getting instructions tips that come with opening Visual Studio Code. Additionally, we have a Visual Studio Code crash course in the GitHub repo associated with this course.
Hello, my name is Vasily, and I'm going to be your instructor for everything related to development on Windows. Installing developer dependencies on Windows is a little bit tricky and sometimes really messy. That's why we are going to install a tool called WSL, or the Windows Subsystem for Linux. On the upcoming videos, I'm going to be really straightforward on how to install the tools we are going to use for the rest of the lessons. However, if you want to actually understand what WSL is, how it works, the basic command line tools, and a lot more, please be sure to check our 100% free crash course about WSL for smart contract developers we published on YouTube. With that said, let's get that Windows environment ready for development. Microsoft has definitely increased their support for developers in the recent years, but when it comes to smart contract development, there is a better option to consider, using WSL, the Windows Subsystem for Linux. Trust me, it's a game changer. You see, smart contract development often involves working with tools and utilities that are commonly found on Unix-based environments. While Windows has come a long way in accommodating developers, there can still be some challenges when it comes to running certain command line tools and setting up the right development environment. Not mentioning that if you want your code to run on any machine using a Unix-based system, Mac and Linux, is better for your developer needs. Here is where WSL shines. By installing a Linux distribution through WSL, you gain access to a full-fledged Unix-like console right on your Windows machine. And don't worry, you don't need to be a hacker or wear a hoodie to make it happen. It's actually quite simple. So let's do it. Let's get started with the installation process. First, we need to install WSL using the Windows terminal. In Windows 11, you can just hit the Windows key and type terminal, hit enter, and this will open the Windows terminal for you, which defaults to PowerShell. However, if you are using Windows 10, you are going to need to install the Windows terminal through the Microsoft Store. So you can open the Microsoft Store, look for Windows Terminal, and please be sure to select the one from Microsoft Corporation. Once you have it, please open it, and installing WSL is going to be a really straightforward process. And on the terminal, we are just going to type WSL --install. This is going to trigger some admin level operations, as you are going to see on the screen right now. You just select yes, hit enter, and once the installation process is finished, this will require you to restart your computer. Once you reboot your computer, this is going to automatically trigger this window to continue the installation. So let me actually make this big for you to see. And the first thing we need to do here is to select our Unix username. I'm going to select Cronware, hit enter, and then we are going to be required to set up a new password. Something interesting on most of Linux operating systems / distros is that when you are using the terminal, if you type anything over here, the password is going to remain hidden. That doesn't mean that you are not typing anything, but the terminal is not going to show anything over here. Unless you use another Linux distro, for example, Linux Mint. Otherwise, most of the Linux operating systems are going to keep this always hidden. I'm going to type my password though, and then hit enter. And as you can see here, the terminal recognizes that password and asks me to type it again for confirmation. And once we finish this, that's it. We have WSL installed on our machine. As you can see here, the installation finished properly and we can continue. I'm going to actually close this for now.
Now that you have WSL set up, you can go to the search bar and look up Ubuntu. You'll see either Ubuntu on Windows or something like Linux or an app like this. And if you click it and you start it up, you'll get dropped into a Ubuntu shell or a Ubuntu application. And it's in this type of shell that we're actually going to be doing work. Another way you can open this up, search bar, you can look for the terminal application. And this is what a lot of coding tutorials are going to teach you how to use. Now, the first time you open it, it actually might take a long time because your computer is booting up an entirely new operating system different from your Windows operating system. And that might take some time. When you open up your terminal, it will default you into this Windows PowerShell. This is not what we're going to be using. If anytime you see a PowerShell like terminal, that should be your cue to know that we should switch over to a Ubuntu or a WSL or a Linux-like terminal. In PowerShell, you can actually select the drop-down here and switch over to Ubuntu in a new tab, and it'll give you that same Ubuntu setup. Now, you can work directly off of your Linux/Ubuntu setup, but we're actually going to be doing most of our work directly inside of the app Visual Studio Code. There are a number of ways to install Visual Studio Code. We'll let Vasily teach you how to install Visual Studio Code because there are multiple different ways that you can get it installed.
There are plenty of ways to install Visual Studio Code, and I'm going to show you 3 of those ways on this video. The first one is going to be using the terminal. As we are going to spend a lot of time using the Windows terminal anyways, we can install it with the hacker/programmer way. For that, we are going to use Winget, which is a package manager pre-installed on Windows 11 for installing software. You can also get Winget on Windows going directly to the documentation. So for example, if I want to install Visual Studio Code using Winget, I just use Winget search VS Code. This is going to show me all the available packages to install Visual Studio Code. So for installing Visual Studio Code using this is going to be really easy. I'm just going to copy this and say Winget install and the package name I just selected. If I hit enter, this is going to start the installation of Visual Studio Code on my machine. As you can see, this is opening the installation for me. And that's it. This is how you install our code editor from the terminal. And if I go to the main menu, I already have Visual Studio here installed. The second way to install Visual Studio Code is open your favorite web browser. On the search bar, look for Visual Studio Code. Select the one from code.visualstudio.com. This is the official Microsoft one. You can click on download for Windows. This is going to automatically trigger the download and open it. This is going to start the installation process. And of course, we have the user and license agreement. Mostly no one cares about this stuff and no one reads it, but I highly recommend you to spend a little bit doing so as a good practice. I'm going to accept the agreement, hit next. This is going to give us the path, and the installation is almost the same as we did on the terminal way, but in this case is going to allow us to have more things like this add open with code action to Windows Explorer file context menu. This will allow us to do a right click here and have the ability to open any folder using Visual Studio Code. I'm going to also create a desktop icon. Hit next and install. On the meantime, this is installing. I'm going to mention that if you are concerned about Microsoft having that much control over the data because they own Visual Studio Code, they own GitHub, they own a lot more of tools, and you want an open source version of Visual Studio Code, that will lead us to the third way, which is VS Codium. VS Codium is an alternative to Visual Studio Code, which is exactly the same, but without Microsoft telemetry, gallery, logo, and etc. So basically they take the basic Visual Studio Code build, remove all the Microsoft stuff from it, and change the license to the MIT license. So basically, if you are concerned about your privacy or Microsoft having access to your data, VS Codium is a really nice alternative. The installation is exactly the same. You hit on install, you download the latest release. This is going to lead you to GitHub, and select the one for Windows. In this case is going to be the one marked as VS Codium user setup.exe. You hit this, this is going to trigger the download, and you're going to have the package to be installed over here. If you open it, this is going to allow you to install VS Codium, but as this is not signed by Microsoft, Microsoft is going to prevent to run this. You click on more info and run anyway. This is going to open the installation, and the process is going to be almost the same because at the core, they are the same code editor. And this is how you can install Visual Studio Code in 3 different ways. Select the one you like. For this tutorial and for the rest of the course, I'm going to keep from the one coming directly from Microsoft Visual Studio Code.
Thanks, Vasily. I'm going to go ahead and install it directly from the website. Now remember, Visual Studio Code is actually very different from Visual Studio. Visual Studio is a completely separate app. Even though I know they have almost the exact same name, we want to use Visual Studio Code. I'm going to download it directly from the website for my Windows application. I'm going to go ahead and hit save. I'm going to open it up now. Accept the agreement. Next, next, next. Create a desktop icon. Add open with code actions to the Windows Explorer. Next, install. Finish, and let's go ahead and launch Visual Studio Code. Now, right away when you open up Visual Studio Code, you actually might even get prompted saying you have Windows Subsystem for Linux installed on your system. You want to install the recommended WSL extension from Microsoft for it, and you can go ahead and hit install. Now, if you don't get prompted with that, you can also go to this extensions bit on the left-hand side here and look up WSL in the extensions. And we want to install WSL here for Visual Studio Code WSL. Make sure you see the little blue check mark to make sure that this extension is coming from Microsoft.com. Let's go ahead and hit install. Now that we have this installed, we can actually reopen up our Visual Studio Code with a Linux or a Ubuntu terminal built directly into the Visual Studio Code. I'm going to go ahead and hit X here. What I can do is I can hit these 3 little drop downs and go to Terminal, select New Terminal. Now what's going to pop up is very similar to our terminal application. It's going to pop up in the PowerShell terminal here. Similar to what we did in the PowerShell application, we can hit this little drop down and switch to a Ubuntu WSL terminal instead. Again, this will take some time for it to actually start loading up. If I type cd in the command line, it'll bring me to what's called the home directory. Additionally, at the bottom left, you'll see this little open a remote window section. If we click on that, you can also select connect to WSL instead, which will open up our VS Code directly in a WSL Ubuntu setup. Now, when I select the three dots and go to terminal, new terminal, it'll open us directly up in a Linux-like or a Ubuntu-like terminal instead of PowerShell. So your cue moving forward is at any time we're working with Visual Studio Code on your Windows, you should see this WSL Ubuntu in the bottom left, because we're always going to be working with Ubuntu or WSL or this Linux-like environment and not the Windows-like environment. If we close out of Visual Studio Code and then we reopen up in Visual Studio Code, we'll see in the bottom left that it's actually going to open back up in Ubuntu. And if we click here and we close the remote connection, you'll see the WSL Ubuntu goes away. We close Visual Studio Code and then reopen it. You'll see it's still gone. So we want to open it back up, connect to WSL, and now we're connected back in the WSL environment. Let's open up our terminal. And there's a shortcut with Control-Shift backtick if you want to use that as well. And boom, we're back in our Linux-like or our WSL-like environment. For the rest of the course, as I just said, this is the environment we're going to be working with. And anytime you work with terminal commands, use the Linux or WSL or Ubuntu-like terminal commands. Don't use the Windows ones. Anytime you're typing in a Ubuntu or Linux shell and a website says, hey, here's the Linux command, here's the Windows command. If you're in this type of shell, if you're in this type of terminal, use the Linux commands.
Now, one of the awesome things about Visual Studio Code is it has this thing called terminals, which are command line prompts that allow us to run scripts. Basically, it's where we're going to be running all of our code. The way we can open up the terminal is we can go ahead and hit terminal and select new terminal. And you'll get something like this. Now you might have bash or ZCH or some other type of shell. The type that you have doesn't really matter because on Mac and Linux, it's going to be Linux based. And like I said, sometimes installing this can be the hardest part of this entire course. So don't get discouraged and please use Stack Overflow, Stack Exchange Ethereum, and the GitHub repo to move past any issues you run into. Now, if you're on Mac or Linux, you can actually hit Control backtick to actually toggle your terminal mode. This will pull the terminal up and down for you. Getting familiar with keyboard shortcuts will actually make your life a lot easier because you'll be able to move around Visual Studio Code much more effectively. We have a link to a list of keyboard shortcuts additionally in the GitHub repository associated with this section. As we move along, I'll give tips on different keyboard shortcuts that you can optionally use. Otherwise, you can just go ahead and click as well. You can click the trash can to delete the terminal, go back up, terminal, new terminal to pop it back up. Now, the next thing that we're going to need a little bit later, we're not going to need it for this section, but it's good to install it now, is going to be Git. We will have links to the installation instructions in the GitHub repository. Installing Git on Linux, you're going to use one of these two commands. And on Mac OS, if you just type Git on the command line, it should go ahead and prompt you to install it. So if we're back in our command line and we just type Git, it should prompt you to go ahead and install it. And if you do git -- version, you should get something that looks like this. You can also use a macOS Git installer by clicking this link here and running through the installation process. All right, now that you have Git and Visual Studio Code installed, we can continue on to the next section. Awesome. If you're not planning on using Windows or Gitpod, feel free to skip the next two sections.
To install Python on a macOS system, we're just going to go to the python.org website, and we're going to download Python directly from python.org. So on python.org, go ahead to download, and it should give you download for macOS right here, and we can hit Python 3.13, and we can hit the button to download that version. However, before you select that actual version, scroll on down, and in the GitHub repo associated with this course, you'll see right at this section 1, Python Crash Course, or whatever section number it is, you'll see Python version 3.11. So whatever version is in the GitHub repo associated with this course, that's the version that we want to go ahead and download here. So to use 3.11, we'll go to Downloads, we'll go to macOS, and we'll look for 3.11. So now that we're in the macOS download section, we'll scroll down and we'll look for the latest Python 3.11 that has a universal installer. So we can see here, there's no files for this release for this version, so we're not going to use that. But by the time you watch this, maybe there will be, but we'll look for 3.11, we'll hit enter. And it looks like this version of Python 3.11 has a macOS installer. And this installation version supports both Apple Silicon, x86/64 versions. So if you're like, hey, I have Apple Silicon or an Intel chip, don't worry, this should work universally on both versions of macOS. So we go ahead and click this. We'll go ahead and save, which will be saved to our downloads, which we'll go ahead and we'll open up into the Python installer. We'll go ahead and continue. We'll agree, install. And it'll go ahead and install this version of Python. Great. Once it's installed, you might get a little pop-up like this. We can go ahead and close it out. It'll say, congratulations, Python, and then the version you installed has been successfully installed. Let's go ahead and close this here and move to trash. Now that Python is installed, we can actually open up our VS Code here. And remember, to open up the terminal, we can either select Terminal, New Terminal, or do Control-Shift-, or do Control-Shift-, or do Control-Shift-, which will open us a new terminal here. Since we just installed, and let's go ahead and pull this to the top. And since we just installed Python 3.11, we can type in Python 3.11 and get dropped into a shell that might look like this. To exit this, we can type quit with an open and close parenthesis, or you can always just close and delete the terminal by hitting the trash can and then open up a new terminal. To make sure you're on the correct version, you can do Python 3.11 - version. And it looks like we're on the correct version here. Now you might also have Python 3 - version, which is a different Python version. As for me, my Python 3 is updated to the correct version. You might also have Python -- version. However, as of recording, I do not have the Python keyword. So if you have, one computer can actually have multiple versions of Python installed at the same time. And this is where some of the confusion can come into play when working with Python. This is why very soon we're going to switch off of Python and move over to a tool called UV and a tool called Moccasin, which are going to make our lives a lot easier to work with these different versions of Python. Now we're going to learn how to install Python in this WSL if you're on a Windows machine, or if you are on a Linux machine, just right on your Linux machine. Now, most of the time, most sites are going to ask you to go directly to the Python website and select download. The issue with this, for those of you on a Windows or a WSL environment, is that downloading directly from the website will download this into your Windows operating system. We don't want to do that because we are going to be working in the Linux, the WSL, the Ubuntu operating system. We want to download into our Linux operating system. The same is actually true for any other software application that you want to run in your WSL environment. You're going to have to download it directly from the command line as opposed to downloading from some website with a click of a button. Now, if you're watching this on YouTube, there will be a link to the GitHub repo associated with this. If you're watching this on Cyfrin Updraft, of course, this will be in the course materials section of the website. We scroll down on in here. We scroll down to, where is it? Moccasin Fundamentals, the Python Crash Course section. We just finished the Google Collab section, just set up Windows and WSL and VS Code, etc. Now we're going to be installing Python on Windows, WSL, or Linux, or Ubuntu. First thing we want to do this new terminal. And again, we want to make sure we're on WSL, Ubuntu. If you're on a Windows machine, if you're on a Linux machine, you will automatically be in this environment. And to even make sure, you can do echo $SHELL, enter. And if you get something like bin bash or bin ZSH, or if you just don't get an error, that's a good sign. If you do get an error, this is a great time to take that error and drop it into an AI like Claude, for example. say, hey, I ran into this error. I'm trying to use my VS Code in a WSL environment, or I'm trying to use my VS Code in a Linux environment. What's going on? Why am I getting this? We can type clear in the terminal and hit enter to clear all the lines. If I have a whole bunch of lines here and I'm like, oh, this is cluttering up my space, I can hit clear like that. And I can scroll up this terminal to make it bigger or smaller by dragging on this horizontal bar here. And just make sure you're on this terminal section here, not debug, output problems, ports, blah, 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 etc. So to install Python, now Python has gone through several revolutions. And one of the biggest ones happened several years ago where Python moved from Python 2 to Python 3. It was a groundbreaking change. And we want to check a couple of things on our system. First, we want to check if Python is even installed. Check if Python is even installed, we can type which Python like that. And if we don't get a response, this means that Python, the keyword Python, is not installed. We can also type which Python 3, see if Python 3 is installed. It looks like on my computer here, Python 3 is installed. Now, for those of you who did follow the WSL instructions, Python 3 will be installed by default with your Ubuntu installation. Now, if you don't have Python 3 installed, don't worry, we're going to teach you how to install it. But if you do have Python 3 installed, you can type Python 3 -- version, see what version is installed. Most Ubuntu installations come with Python 3.8. Now, a lot of this Python versioning stuff can be very confusing. And we're actually going to fix and make it way, way easier for you later on in the course when we introduce the tool called UV. But for now, for this section, we know that a lot of other Python tutorials are going to teach you how to install it directly, which we think is a little bit confusing. But we want to at least walk you through those steps as well so that you can see what the differences are when we move over to UV. If you don't have Python 3 installed, that's okay, because what we're going to be showing you now is going to install a completely different version of Python anyways. So let's minimize VS Code and let's go ahead and let's run these commands to install a specific version of Python. As of today, we're going to be working with Python 3.11. So first, let's just go ahead and copy paste some of these lines. Sudo apt-get update, this will update our packages. And remember, it might be a good idea to even ask your AI assistant as you write some of these commands, hey, what do these do? Understanding these commands will help you be a better programmer in the future. So if I say, hey, like what does sudo apt-get update do? Claude gives me a great explanation. Again, Claude version 3.5 is currently my recommended AI. You'll get the sudo apt-get update command refreshes your system's package index. Let me explain what that does, and it tells you a lot about what it does. So let's go ahead and let's paste this into our terminal here. And obviously we'll get prompted for our password. We get prompted for our password because we're using the sudo command. Sudo command stands for super user do. Apt-get update means just update our packages. And it's going to update all of our packages so that we make sure we have the most up-to-date versions. Then we're going to do sudo apt-get install software properties common. This is going to install one of these Linux packages on our machines. Great, looks like I've already got it installed here. Then we're going to do sudo apt-get repository ppa deadsnakes/ppa. Again, if you're like, what is going on here? Claude v3.5 is great at understanding this, or most AIs are great at understanding this. And it says, this command adds a personal package archive to your system, specifically the deadsnakes PPA, which is a popular repository for Python versions. This is basically how we're going to get different Python versions onto our environment. So let's go ahead, let's paste that in here, and let's hit enter. You'll notice that we don't have to type in our password again because our terminal remembers that we just recently added our password. Let's go ahead and hit enter to continue, and it's going to go ahead and install this in our Linux environment. Next, we'll do a sudo apt-get update again, just to make sure everything is up to date. And we're up to date here. And then finally, we're going to now be able to install a very specific version of Python. I'm going to run sudo apt-get install Python 3.11. Now, if as of recording, we're going to use 3.11, but whatever version the code says to use, we'll go ahead and use that. And we'll paste in sudo apt-get install Python 3.11 and hit enter. Now, if we type in Python 3 -- version, you have Python 3 already installed previously, it'll still show Python 3.8. But if you type Python 3.11 -- version, you'll see Python 3.11.10. So installing Python 3.11 gave us this command, Python 3.11. So we can now do which paste Python 3.11, which will show us, hey, we do indeed have a Python 3.11 instance installed. Now, for you Windows users, you have everything set up the way that it's going to work in Cyfrin Updraft and this course. Now, even though I just had you go through all this work to download Python 3.11 or whatever version, again, is in the GitHub repo associated with this, we're very quickly going to move away from using Python 3.11 in the terminal like we're doing it here. We're not going to be using this Python 3.11 very soon. We're going to move over to working with UV and working with Moccasin, because using those tools, we're not going to have to worry about Python versioning anymore. There's a couple of really annoying things with working with Python, or to be honest, even Rust, Node.js, or really any programming language, is that some features are only supported in certain versions, and some packages, some features of the language in some open source packages or tools or libraries, some things about the languages are only supported in certain versions. So using tools like Moccasin and UV will allow us to much easier switch between versions, use tooling with versions in the correct way, and so on. So for now, let's just do a quick recap because I know there was a lot in here. First off, number one, if you're on a Windows machine, in the bottom left, you should see running on Ubuntu with this WSL Ubuntu or whatever Linux version that you chose. In the terminal here, if you hit this little trash can and then you go back up and you select terminal, where is it? New terminal, should enter you in this Linux-like terminal. You can make sure you're in a Linux-like terminal by typing echo $shell. And if you get an output that looks like this and it doesn't look like an error, you are probably in a Linux or a Ubuntu-like terminal. Now, for you Windows and Linux users, everything else in the rest of the course is going to be pretty much exactly the same here. And it doesn't matter if you're on a Windows, a Linux, or a Mac, as long as you have this terminal here to the Ubuntu environment, you're going to be perfectly able to do everything that everyone else is going to use. If you do run into an issue, as I've said many times, Googling, joining the discussions forum, and using AI will be incredibly helpful for you to move forward here.
So now we're opened up in VS Code. If you're on a Mac OS or a Linux machine, the bottom left-hand side should just basically kind of look like this. If you're on a Windows machine, the bottom left should say like WSL or Ubuntu or a combination of the two. But now from here on out, all operating systems can run the exact same commands, whether or not you're Mac OS, your Windows, or your Linux. We're always going to be using the Linux or Mac OS like commands moving forward. This way, the instructions will always work no matter what. Again, if we pull up our terminals here and we type echo $shell, it could say ZSH, it could say bash. There's many different types of shells out there that all work the same. Doesn't matter which shell that you're using, because the commands that we're going to run will all work no matter what shell you're working with. I've mentioned this a couple of times, but just to reiterate, oftentimes my terminal here will get kind of bogged down with a lot of lines. And what I'll often do to clear it is I'll either type clear in the command line to clear all those lines, or I'll type Command K for Mac OS, or this is also Control K for Linux or Windows. So the shortcuts are the only thing that will be a little bit different depending on if you're on Mac OS or Linux. Additionally, the trash can and the X here are actually very different. The trash can here means to delete the terminal. And anytime I say delete the terminal, that's usually what I'm referring to. If I just say like close the terminal, I often just mean hide the terminal. So if we were to do terminal, new terminal, let's pop up a new terminal, and I did a couple of lines here. If I were to hit the X here, I'm actually just going to hide it. I'm going to hide the terminal, but I could pull the terminal back up. Now, if I do terminal, new terminal, you'll actually see that now I have two terminals. If we scroll up here, we can see that this other terminal is the one with all the new lines, and I just created a new terminal here. So I can trash one of the terminals, and that one is now deleted. I can also create a bunch of new terminals, but typically most of the time we want to work with just one terminal. There are some scenarios where we want to work with two. Now to toggle the terminal to basically hide it and then pull it back up, you could do Control-tilde on a Mac OS. On Windows or Linux, it's going to be Control plus backtick. So Command backtick for Mac OS, Control plus backtick for Windows and Linux.
And this is the same as hiding the terminal and then hitting view and selecting terminal. So again, command backtick, this will toggle hiding and showing your terminal. You can also do view terminal to hide it and then view terminal again to show it. And hiding it is equivalent to pressing the X button here. I'm on a Mac OS and I also use Command J a lot, but that keyboard shortcut might not be the same for everybody. Now, this is very different from the trash can icon here. If I hit enter a whole bunch of times, and then I go ahead and do trash can, and then I toggle or re-show the terminal, you'll notice that those new lines are no longer there. Whereas if I do a bunch of new lines, hide the terminal, and then bring the terminal back up, those new lines are still here. This trash can means to delete and remove everything in the terminal or kill the terminal, whereas the X is just to hide it. Now, let's get started setting up your Visual Studio Code so that it's going to be very easy for you to all your files and projects that are related to this course in a single folder. So let's go ahead and let's open up a new terminal, again with Control or Command tilde or Command J or view terminal or terminal new terminal or whichever command that is most applicable to you. Now, a number of the commands that we're going to be running are known as Linux commands, and they work on ZSH, they work on Bash, they work on pretty much any shell that comes with Linux or Mac OS, or if you're on Windows, Windows WSL. You can see what directory you're in by typing pwd. This will show you which folder that you're inside of. When I typed pwd here, I'm inside of users/Patrick. I'm in the Patrick folder. This is known as your home directory. If you type cd, which stands for change directory, you will change directory to your home directory. This little tilde stands for the home directory. I could also type cd tilde, hit enter, and then type pwd again, and you can see I'm in the exact same directory. It's because I changed directory to my home directory here. For all of this Cyfrin Updraft course, I recommend you making a brand new folder specifically to hold all of your files and folders for this curriculum. So let's create a new folder, mkdir. Mkdir stands for make directory, which is a command to make a brand new folder. We'll do mkdir and we'll give our folder a name. I'm going to call mine mox-cu, which stands for Moccasin Cyfrin Updraft, but you can call it whatever you want it to be. If you want to be a little bit more specific, you could say Viper course, you could say Updraft, Python, whatever you want to type in here. So I'm going to say mox-cu, and then we can do cd mox-cu, which stands for change directory, mox Cyfrin Updraft. And now you can see right here, my terminal tells me that I'm in the mox-cu folder. Depending on which shell you're working with, you might see something else here, but this is currently what I see. If I type pwd, you can now see I'm in the users Patrick's mox-cu folder. If you're on a Mac OS, and yes, sorry, this is a Mac OS specific command, I can type open period, and this will open up that folder inside of my Finder. I don't have any files in there, so obviously it's empty. And I know I said every command is going to work the exact same, no matter if you're on Mac or Windows or Linux, but there's actually some slightly different commands for Windows and for Linux here. For Windows users, a similar command is explore.exe period, which should open you up in the Windows Explorer. For Linux, it's going to be xdg-open period, which will open you up in the Linux folder. For Linux users, you might not have this installed by default, and you might have to do sudo apt-get install xdg utils to install this. But again, if you don't have this command, it's not really that important. Now, this folder here, remember, let's type pwd. This folder here is where we're going to store all of our different projects. And this is where we're going to build up our resume and build up our learnings to become successful smart contract developers. Now, what's especially cool about VS Code here is that we can do file, open folder, and choose our folder that we just created, this mox-cu or whatever you named it, select open, and we'll actually open up a new VS Code where the default directory is this folder. If I select terminal, new terminal now, or use the shortcut, and I'm going to hide my Explorer by pressing this little button here. If I do pwd now, I can see I'm directly in this mox-cu. And if I hit the trash can, terminal, new terminal, or the keyboard shortcut and then type pwd again, I'm still inside of this folder. Another shortcut that we can do, and if you haven't installed it, that's okay. You can always do file, open folder, like what we just showed, but you can also do code, period, and this will also open up a new window inside of this folder here. File, open folder, and then select the folder you want to open, or code, period, if you're in the folder that you want to open up. Once you are inside of the folder, this button over to the left here is known as the Explorer, and it will show you all of the folders on the left-hand side. If I were to right-click and hit New File and do something like hi.txt, I now can see this hi.txt on the left-hand side. In my terminal, if I type ls, which stands for list, I will list all the files and folders inside of this folder, and I can see there's just currently this hi.txt. If I were to create another file with doing right-click and then new file again, called hi2.txt, and now in my terminal, I do ls, I can see hi.txt and hi2.txt. I'm going to delete this. What's cool is I can even edit these files directly in my VS Code. Some stuff here. Now, what's important to note is that if you see a little dot up here, this means this file is unsaved. So to save, we want to hit File, Save, and you see the dot goes away, which means it's saved. This is incredibly important because if you forget to save stuff and you try to run commands, they won't work. So I always use the keyboard shortcut, which on a Mac OS is Command S, and for Windows and Linux, it is Control S. So type some stuff, see this little dot here, Command S, boom, the dot has gone away, and now it is saved. And now I can flip back and forth between my files and know that they are being saved. Unsaved, saved, unsaved, saved, unsaved, saved. It's really important for you to recognize that because oftentimes you're going to run a command, you're going to be furious that it's not working, and you just forgot to hit save. So I have a trigger finger after years of programming where I just always hit Command S or Control S on my keyboard all the time. So you'll see me run commands and almost by force of habit, I have already saved the file because anytime I pause to think for a second, I've already hit save. You could also delete any files in your folder directly from your VS Code by right-clicking a file, selecting delete. Are you sure you want to delete? Let's move to trash. Then we could toggle our terminal again, type ls, and we can see that file is no longer in the folder. And of course, we can see it over here. Final thing that we want to install, and we'll install a lot of these as we go along, is actually an AI extension, something in VS Code to help us actually have AI inside of our Visual Studio Code. If you select this little box looking thing that says extensions, you get a search box which allows you to search for extensions. The AI that I work with the most is GitHub Copilot, but you can use whatever AI you want, or you could just not even use an AI. GitHub Copilot does cost money to use, so feel free to also not use it. There's some other free VS Code extensions that use AI, so feel free to browse around and choose which one you like. For me, I'm going to go ahead and install GitHub Copilot. You'll get a little guy in the bottom right for your VS Code that will let you know that you've done it correctly. You'll need to sign into GitHub, which is something that we've recently made, in order for it to work. You might also want to install GitHub Copilot Chat. This will give us a chat box for GitHub Copilot, where if we click the little GitHub Copilot icon, we hit GitHub Copilot Chat, we get a little chat box similar to Claude or ChatGPT right in our VS Code. Now, you'll see me using GitHub Copilot pretty often when I write my code. Because I have this little doodad on down here, I can start writing some code and GitHub Copilot will start giving me suggestions as to what I should write. For example, if I were to add spdx license identifier, GitHub Copilot actually automatically starts to gray out and give me a suggestion. If I hit tab, I can auto-complete my code with GitHub Copilot suggestion. You can go ahead and click the little doodad, go to GitHub Copilot Chat as well, and you'll have a chat box very similar to something like ChatGPT or Claude or whatever. You can also choose the different model by hitting this little dropdown, and I know mine kind of pops off the screen here, but you can see there's different models that you can use. GitHub Copilot does cost money to use, so please use the AI of choice that you prefer to work with. So at this point, you'll have everything set up to start going. If you've chosen to add GitHub Copilot, let me zoom out a little bit. Down in the extensions section, you will see a GitHub Copilot, and this will be, you'll see a little disable button because it's currently enabled. you can click on the little GitHub Copilot to get a bunch of commands to run with GitHub Copilot. We will be in our mocks.cu folder, which you'll be able to see at the top here. And if we hit our little file explorer here, we can see all the different files in here. We can toggle up our terminal by hitting Control tilde, which will pop us into our terminals here. Now, I'm always trying to be positive to myself, so my terminal always tells me to make it a great day, but your terminals will probably a little bit more neutral in tone than mine. You should have Python 3.11 in your terminal, and you can make sure you have it by doing Python 3.11 -- version. So now that we have this all set up, we're finally going to do some Python coding in our project here. And we're going to be showing you how we do Python in Cyfrin Updraft and how we work with Python in Cyfrin Updraft. Later on, we're going to be teaching you how to work with Moccasin. But first, we're going to be doing some raw Python, because the raw Python will teach you what's going on under the hood of this tool, Moccasin, that we're going to learn later on. So we're going to get started with Python. We're very soon going to move to using this tool called UV, but you're all set up. So let's finally jump into doing some Python. And the reason I spent so much time getting this set up for you, and the reason we spent so much time installing and blah, 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 is because being in the middle of a project and then something not working the way you'd expect is one of the most infuriating things a developer has ever gone through. And as a developer and a software engineer, that is something that will happen to you. AI tools like Claude and ChatGPT and GitHub Copilot directly in your VS Code will make debugging these a lot easier, but I spent so much time so that we greatly lower the chance of us running into those problems. And additionally, we spent all this time getting this set up because this is how professional smart contract developers and professional Python developers work. Making sure your environment is as close to production as possible will ensure you write the highest quality code. And unlike a lot of other Python tutorials out here, I'm not here to show you something that isn't what professionals use. I'm here to get you career ready, to get you to becoming a powerful force for the blockchain and the Python community. I'm here to set you up so that when you leave Cyfrin Updraft, when you stop watching these videos or reading these blogs or stop learning on this platform, you get out there and you just start cooking. Going to make you a chef of the software engineering persuasion, and teaching you all the badass stuff right from the get-go is how we're going to get there. We are going to do all of our practice in a real coding environment, because that way you will get comfortable in this real coding environment with all the obstacles that come with it. We teach you how to do real stuff, real projects, real workshops, so that you can get out there and go, oh, yeah, I already know how to do this. We learned this in Cyfrin Updraft. Now, one more thing I want you to do, and I know I just said we would actually get started coding right now, but one more thing I want you to do before we get started coding. Go into your file explorer. Let's go ahead and delete this hi.txt. Delete. Type in pwd. Make sure you are in your folder that's going to hold all your projects for this Moccasin, for this Viper, for this Python course. And I want you to create a new file called readme.md. .md is the extension for Markdown. And the readme file is a classic file that pretty much all coding projects will have that explains to people what this project is about and what it does. We're going to create a README for your learning journey. And in this readme.md, I want you to write and answer these questions. First off, why am I learning Viper and Python? Next, what do I want to do or be when I finish this course? And then finally, what are the steps I'm going to take to get there? The reason this is so important, and the reason I want you to do this, is because in the future, what's going to happen is you're going to come across things that are difficult. I'm not going to placate you and say software engineering is incredibly easy. There are many days where I'm banging my head up against the wall when I'm asking my AI assistant how to fix something, and it keeps giving me solutions that aren't working, and I get frustrated. So in those times of frustration, you can come back and you can go, is this all worth it? Why am I doing this? Now, the reason that you're learning Viper and Python is going to be different from people to people. And it's unique to you. Maybe you want to just be part of the blockchain movement and be part of this amazing system of no centralized intermediaries, non-custodial finance, the future of money. Maybe you're just saying, you know what, Patrick, I just want to get a job and I want to make a lot of money and I want to be a force for good. Maybe you just want to learn a new skill. Maybe you want to be able to build your own products, become an algorithmic trader. Whatever the rationale is for you, write it down here and be honest. Don't placate yourself. If you're like, hey, honestly, I just want a job so I can buy a Lambo, put that in here. Be honest with yourself. Next, what do you want to do/be when you finish this course? What is it going to feel like when you're done? Do you want to be a software engineer, a security researcher, a technical CEO, a technical BD. What do you want to do? What do you want to feel like when you're finished with this course? And then finally, what are the steps you're going to take there? This is a long course. There's a lot of code here. There's a lot of things for you to learn before you're good enough to go off on your own. So what are the steps you're going to take to do there? Maybe it's 30 minutes. Maybe it's 30 minutes a day for 4 days a week of Cyfrin Updraft. Maybe it's 1 hour a day or every day. Maybe you only have 2 hours on Saturday. Whatever you're going to do, try to come up with a cadence and stick to it. And if you get frustrated because you're not hitting your pacing that you set, it's okay. You can change the steps in here. Maybe you come back and you go, you know what? 2 hours a day on Saturday was too hard. I'm just going to do 1 hour a day. 1 hour a day on Saturday. 7 days a week was too much for me. I'm going to move it down to 3 days a week. Whatever the pacing works for you, try to come up with a pacing schedule and stick to it, because that is going to be how you're going to be the most successful here. So write up this readme.md. This will be your manifesto that you can fall back to when things get hard. And don't share this with anybody. Studies show that when you share your goals with people who aren't going to keep you accountable, you actually lose some motivation. You've probably told somebody before, hey, I'm going to go out and do this. And they go, wow, what a great goal. Them telling you, wow, what a great goal, actually saps some of your motivation. You're getting a reward for not even having done anything yet. They're saying, wow, that's so exciting. And you might say to yourself, wow, you know what? This is a great goal. I feel pretty good about myself. But you don't want that to happen because you haven't done anything yet. You should celebrate and you should share the small wins. But goal setting is not a win. So set these goals here, set them for yourself, keep them private to you, and be honest with yourself. All right, now that we have this out of the way, now let's finally begin coding and let's start this phenomenal journey that you're being set on. All right, so you're in your Mox Cyfrin Updraft folder, and if you hit ls, you probably just have this readme.md file in here. Let's go ahead and let's create our first project folder. And this is going to be our Python in Updraft folder. We very recently, we did all this work in Google Colab, where we learned a lot of the basics of Python. And if you followed along with the Viper basics, we learned a ton about Viper as well. So what we're going to do now is we're going to start using some of this Python in a more professional environment. So I want you to create a new directory, mkdir Python in updraft cu. Or you can do, or if you want to keep these in order, you can also do -Python in updraft cu to number it, but whatever you want to do. Then hit enter. And if you do an ls now, we now have a file and a folder. And if you go to the Explorer, we have a folder that looks like this and a file. And now we can do cd python in updraft -cu. Now, before you hit enter, a quick little tip is if you start typing the folder name Python in and then hit tab, it will probably autocomplete the folder name, and then you can just hit enter. And now if you do pwd, you can see we're inside of this folder. Now I want you to open this up in its own folder. You can do that by either typing code, period, if you've installed this functionality, or you can do file, open folder, and then choose the Python in Updraft CU folder. I'll hit enter, and we're given a new window where if we pull up our terminal here, let me zoom in a bit, and we type pwd, we can see we're automatically stuck into this folder. Now, if you're following along with the course, at this point, you have Python 3.11 installed. And one of the quickest ways to try stuff out in Python is to enter what's called the Python shell or the Python console, where we can just write anything we want. To get started in there, we can just do Python 3.11, hit enter, and this will drop us into a Python shell. This is actually very similar to the Google Colab that we did before. We could type print hi, and we'll print out hi. We could type my var equals 7, hit enter, and then nothing happens. And now if we type print my var, it'll print out 7. So this is where we can kind of quickly test and work with different Python things. Now, if I hit type quit and I exit the shell, and then I type Python 3.11 again, we'll re-enter the shell. But if I try to do print my var now, print my var, I'll get an error. My var is not defined. Every time you quit your shell, it does not save what was in the past shell. So I'm going to go ahead and delete the terminal, pull up a new terminal. And again, if I do Python 3.11 one more time, I still can't do print my var. It still gives me an error. So delete the terminal, pull up the terminal, and that's how you can enter and exit a Python shell. VS Code is really powerful though. And one of the things we can do, if we want to, we can create an environment very similar to this Google Colab environment in here. What we can do is in the left-hand side here is we can create a new file called cells.ipynb like this. Now, if you click on this cells.ipynb, you get a pretty similar setup to what we saw back over here in Google Colab. And in fact, we can even select plus code and do some print hi in here, and we'll be able to run this very similar to Google Colab. Now, it won't run right away. If we hit the play button here, or you type in Shift Enter to try to run the cell, it'll give you a little pop-up saying install/enable suggested extensions, Python plus Jupyter, or browse marketplace for kernel extensions. Let's go ahead and let's delete this. Don't click that quite yet, although if you do, that's also fine. Our ipynb file in VS Code needs a VS Code extension for us to be able to run these. So if we select the three dots and go to extensions, or just click the extensions button on the left-hand side here, we can look for JUPYTR and look for this Jupyter Notebook extension to help us work with these notebooks. And we'll go ahead and install this one. And then additionally, we're going to want to install the Python extension. So we'll type in Python, we'll select this, and we'll install this as well. This Python extension will give us a lot of really helpful tools, including syntax highlighting, formatting, and a lot more other stuff. You can see all the different extensions that you have installed in the installed section here. I've got a number of different extensions, and the Jupyter extension comes with even more extensions as well. Now, back over in here, if I hit plus one more time, it still won't run because I need to select a kernel source. I'm going to go ahead and hit Python environments, and you'll see a couple of different environments here, depending on how you installed Python. I'm going to work with this 3.11.9 because this is the Python version that I went ahead and installed recently for us. So I'm going to go ahead and choose this. And now you can even see we get some syntax highlighting here because now we have a kernel and we have the Python extension. And then finally, if you get a pop-up like this, which you probably shouldn't, but you can go ahead and hit install to install this other ipykernel extension for your VS Code as well. And now finally, we can see the output hi in here. We can additionally do other basic Python stuff like myvar equals 8, shift enter to run the cell. And then we can do something like print myvar, save, shift enter, and it'll print myvar. And even down here, we can do print myvar, save, shift enter, and it'll still print 8. We can have these Google Colab type notebooks, also known as Jupyter or IPython notebooks, directly in our VS Code. And if you want, in the GitHub repo associated with this course, if you want to play with it, the entire Cyfrin Updraft IPynb notebook that we used in Google Colab is available for you to download in the GitHub repo, Python in Updraft, Cyfrin Updraft. So great. So now we know how to work with cells.ipynb. Let's now create our first basic Python file that is how professional software engineers work with Python. So Google Colab and these notebooks are great for testing and tinkering and learning and working with stuff and the like, but they're not great for professional environments because similar to Remix, if I wanted to test something and I had to do like shift enter or execute all these cells at the same time, it can be very disjointed, it can be very annoying, and this isn't how professional projects work. What they do instead is they create Python files to run and execute. So for example, I'm going to create a new file called basic-python.py. The .py file extension is how VS Code and other Python tools know that this is a Python file. In here, we can type and run kind of the basic Python stuff. Again, I can do print hi in here. Remember, this little white dot means it's not saved. Hit Command S to save it. And then I could hit this little plus button that comes with this, and it'll run my Python file with this hi. Now there's a whole bunch of other stuff that it'll do. And so this is kind of like a cheat sheet shortcut. And this is something that you can use to run your Python files. However, we're going to discourage that use for a lot of reasons. Instead, in your terminal, if you do ls, you can see we have this basic python.py. We're going to write Python 3.11 basic python.py. Let me zoom out a little bit here so you can see the whole line. Python 3.11 basic python.py and hit enter, and we'll see it prints out hi. So this is how we can execute an entire file of Python like so. Now, another thing that you can do in Python is you can install packages and libraries very easily. We go online to the Titanoboa GitHub repository. We can see this Python package called Titanoboa, which is a Python tool for interacting directly with Viper. If you scroll down to the installation, you can see how to install this Python package directly into your environment. Pip install Titanoboa. Now, we're actually going to use pip not very often. And depending on how you installed your Python, you actually might not even have pip installed at all. If you type which pip and you get pip not found, you don't have it installed. But you kind of secretly do have it installed because we did install Python 3.11. What you can do to work with pip is you could type Python 3.11-m pip, and then you can do any pip command. So we could do -- version, and we could see the pip version right here. So let's go ahead and clear. To install this Titanoboa package into our global environment, we could do Python 3.11-m pip install Titanoboa, hit enter, and this will install Titanoboa into our global Python 3.11 libraries. I'm going to go ahead and type clear in here, and we can actually see a list of all the different packages we have installed by typing Python 3.11-m pip freeze, hitting enter, and we'll get printed out a list of all these different packages that have been installed in our Python environment. Depending on how Python got installed, you might have a ton, you might have very few, but we will at least have Titanoboa. If we scroll down in here, we should see Titanoboa right like this. And it might be a different version than what you see here, but all good. So we've installed the Titanoboa package into our global Python environment. Now that we have Titanoboa installed, we can actually run commands using this package in our Python. So one of the things you can do with Titanoboa is you can actually evaluate Viper directly in Titanoboa. Work with a Python package, we would type import and then the package name, which I know the package name here is Titanoboa, but to import the Titanoboa package, we actually do import boa instead of import Titanoboa. You can see a little hello world here. This is actually exactly what we're going to follow. We would type import boa, and then to evaluate some Viper, we can do print boa.eval empty uint256. So empty uint256 is actually some valid Viper. And this is the way to create an empty uint256 object, aka 0. So if we print boa.evaluate this Viper code, it should print 0 because empty uint256 is Viper's way of getting us 0. So now if we pull up our terminal, let me kind of minimize it here. Let's clear it out. And we do Python 3.11 basic python.py. We'll see it takes a second to run, but it'll print out 0 for us. Now we're going to give you a lot of information about Python versionings, virtual environments, and all this other stuff. And if this all doesn't sink in with you right away, don't worry. It's not critical to your learning journey that this all gets absorbed right away. As we code more and more, you're going to get better and better at working with Python and working with different tooling. And I'm going to be giving you tips and tricks along the way throughout your journey here. AIs are great at helping debug. And for the moment, it's just best to follow along with the commands that I'm going to give you so that you get used to typing them and coding them as you code along with us. Now, one of the issues that can happen behind the scenes is that Titanoboa could have some features that only work with certain versions of Python. Maybe for some reason we run Python 3.11 basic python.py and we get some crazy error and we're not really sure what's going on. This is because certain packages might work with only certain versions of Python. And this can be incredibly frustrating to be on the wrong version of Python and then have to go through that whole process of installing the other version of Python. And then we have like 18 versions of Python, like Python 3.12, 3.13, Python 3.5, 3.6, blah, blah, blah. And that can get really annoying. Additionally, Titanoboa can have different versions. Our Python packages can have different versions. So we could have a different version of Python that only works with certain versions of the package, and a different version of the package that only works with certain version of, and it gets even more complicated when you have multiple packages that only work with certain versions of other packages. And this can be kind of a nightmare. So this is why for the duration of this course, we're going to be working with this tool called UV. It's an extremely fast Python package and project manager written in Rust. It's incredibly fast and it's incredibly modern, and I'm so excited to be showing it to you now before you run into all the headaches that other tutorials don't teach you. UV will help maintain both our Python versions and our library versions, so we pretty much never have to deal with that headache again. Maybe you already dealt with it now, maybe you've never dealt with it, but it will deal with all that. Additionally, when we get to virtual environments, which will come very soon, UV will deal with all the virtual environment work as well. So let's go ahead, let's install UV, and then we're going to show you how to work with UV, how to work with virtual environments, so that whenever we create projects in Python, they're incredibly professional, easy to reproduce, so that anybody can work with it. So if we're in the UV documentation, let's scroll down to the Getting Started section to install UV. And again, there's a link to this in the GitHub repo associated with this course. For those of you on Windows WSL, you're not going to use this command. You're going to use the macOS and Linux command in your WSL Ubuntu environment. And then obviously for macOS and Linux users, you're going to go ahead and additionally use this command. So we'll go ahead and copy this line, hop back over to our terminals, our VS Code. I'm going to zoom out just a little bit. I'm going to pull this to the top, and we're going to paste this in here. This is going to install the UV and UVX commands onto our computer. Once you have it installed, you can go ahead and delete your terminal and pull your terminal back up and type which UV to make sure it was installed correctly. And you can type UV --version to see the current version of UV that you're working with. Now that we have UV installed, what we can do is create a new professional Python project using UV init. And we'll see initialize project Python in Cyfrin Updraft CU, and you'll see a whole bunch of new files on the left-hand side here. Let's go through what some of these files have done, and let's go through why this is green here. First off, we have a git ignore. This is a file specifically for working with Git and with GitHub, and we'll learn about Git and GitHub much later. We have this Python version file, which literally tells other developers and other tools what version is recommended for working with this tool. This is kind of optional, and sometimes you'll see a lot of projects delete it or not have it. We obviously have our two files that we created. We're given a hello.py, which has this very weird syntax, which we'll understand in a minute, and we'll get this pyproject.toml here. Now, this pyproject.toml is an incredibly important file. Whenever we're creating packages, whenever we're creating Python projects, it's this pyproject.toml that will tell the world and other Python projects how to interact with our Python project here. And then, of course, we have our readme.md, which every single one of your projects should come with. You may also see this little main section here, and we'll explain that in a little bit. Now, what's cool about UV is, again, let's look at this basic python.py. If I run Python 3.11 basic python.py, let me zoom out so we can see the whole line here, and I hit enter, we'll see it prints out 0, right? We could even print something else out. We could print hello, like so. And let's go ahead, we'll rerun this. We can print it out 0 and hello. What I can also do is I can run this with UV. I could say UV run Python 3.11 basic python.py. But you'll see I'll get an error saying file not found, no module named boa. Now this is where the multiple versions of Python can get a little confusing, and this is where UV is going to help us out a ton. We tried to run this Python script, which has this Titanoboa package, but we ran into an issue. It said, hey, no module named boa. This is because Titanoboa was installed in our global or our base or our site-wide Python packages. Taking a look at, for example, at this image here. When we installed Python in Titanoboa, we installed it into our global environment. So in our global environment, we had Python 3.11, with a package of Titanoboa. In our UV environment, as of right now, we're not sure what Python version it's working with, and we're not sure what packages we're working with either. So if we go back to our terminal, let's go ahead and clear. If I type UV run Python -- version, I can see it's actually Python 3.11.6 versus if I type Python 3.11 - version, the global one is 3.11.9. So if I come back over here, we know that our global Python version is 3.11.6 and our UV Python version is 3.11.9. Or excuse me, other way around. This one's 3.9 and this one's 3.6. Now, let's say, for example, that this script required a certain Python version. For example, I could do import sys, and don't worry about understanding this code quite yet. I'm going to paste this in here. If sys.version.info is less than 3.12, raise runtime error, the script requires Python 3.12 or higher. So this is kind of a quick way for me to say, hey, this Python script only works with 3.12. If I clear my terminal, I can do Python 3.11 basic python.py, which worked 2 seconds ago when we ran this. But if I run this now, we're going to get an error. Runtime error, the script requires Python 3.12 or higher. Well, that's really annoying. So does that mean I have to go back to python.org, download Python again, make sure it works in the terminal here, and then work everything with Python 3.12? This type of mentality, or this type of error, occurs on a lot of Python packages and a lot of Python scripts because different versions of Python have a lot of different features. So this is why coding with Python like this, in my opinion, is a little bit discouraged. Even more ambiguous is if you just do Python 3, if you have Python 3 installed, basic python.py, you're not even sure what version of Python 3 this is. It could be 3.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Obviously, you could check using Python 3 - version, but this can be very annoying. So what we can do instead is we could do UV Python install 3.12, and we can just directly install Python 3.12 into our UV tool. Then we can run the script, no problem. Now we still have the error of BOA, so I'm actually going to comment out BOA for a second here. So now let me comment out the BOA things for that because I'm going to come to that error in a second. But now if I use UV Python list, I will actually be able to see a list of all the different Python versions I've got installed on my computer. Now I've got a whole bunch of different versions, so that's why you see so many here. Now if I try to run UV run Python basic python.py, I'm still going to get this error saying this script requires Python 3.12 or higher. What I can do though is I can do UV Python pin 3.12 to update the .python - version of this project to 3.12, and we can see that it even updated in this file here. Now if I clear my terminal, and I'm going to hit up a couple of times, like literally the up key. Up is a way to kind of cycle through previously run commands. To rerun UV run Python basic python.py, again, I'll hit enter. Now we can see it does a little bit of setup real quick here. We see the hello printed out correctly because that's what the print line is doing. And I can clear again, hit up a couple of times. I no longer get that setup because it's already set up for me, but we have pinned the Python version to 3.12. I could even update this to 3.13, save it, hit up again, hit run. It'll automatically download 3.13, update our virtual environment, which we'll explain in a little bit, and then run the hello, once again, the hello here. So UV is a great tool for actually automatically, very easily switching between Python versions. All you got to do is update this .python version.py. You no longer need to do Python 3.11, 3.12, run, blah, blah, blah. All you have to do is UV run Python, and it'll automatically detect the correct version in this .python version right here. If you want to choose a specific version of Python, you can also do UV run -- Python, 3.12, Python, basic python.py, and it'll run our basic python.py script with 3.12.17 because we didn't specify a minor version here. So I'm going to go ahead and delete this line now. But what I wanted to show you was that UV is a great tool because it helps us automatically work with a correct version of Python based off of this Python version file here. Now, let's get back to our packages issue. So as of right now, let's uncomment these lines here. Now, if I pull up the terminal and I run Python 3.11 basic python.py, we get correctly printed out 0 and hello. Because when I installed Titanoboa, I installed it with Python 3.11 pip install Titanoboa like this. This installed Titanoboa inside of this Python 3.11 global packages area. So it was only installed for Python 3.11. If I were to switch to Python 3.12 or 3.10 or any other version, Titanoboa would not be installed. And that can be really annoying to have to install Python, to have to install packages on different versions across different projects, et cetera, et cetera. And this is, again, where UV helps us out. To add a package with UV, instead of doing that pip install stuff, we do UV add Titanoboa, like so, hit enter. And this will automatically add the Titanoboa package to our project here. And you'll see on the left-hand side here, a brand new folder called venv and uv.lock, which we'll talk about in a little bit. But now that we've added Titanoboa to our project, we can do, once again, uv run python basic python.py. And now, after a little bit of a brief delay, I should not import sys anymore as well, we correctly get 0 and hello. What's cool about this is we can flip between different Python versions. We can flip between different package versions. We can flip between any weird dependency management issues, and UV run Python will always handle it all automatically for us. We don't have to think about installing Titanoboa on these different versions and installing these different packages all over the place. We can just do UV run Python and it handles everything for us. So when we did UV add Titanoboa, that was sort of equivalent to adding it to our packages in here, Titanoboa, in our UV virtual environment like so. And UV allowed us to do Python, whatever version that we want, and additionally, however many packages we want, being able to flip back and forth between them, no problem. Additionally, after we run UV add in our pyproject.toml, we'll now see this dependencies section. We'll see Titanoboa added in this dependency section, saying that our whole project now needs Titanoboa, this Titanoboa package to work. Now, even though we just said that, okay, UV allows us to have any Python version that we want, there's technically what's going on behind the scenes is UV is setting something up called a virtual environment. Back in our Cyfrin Updraft, I can type UV-venv, and it'll say creating a virtual environment at .venv. Now, if you've been following along, that folder is already there, and I can run UV-venv again, and it'll still do the same thing, creating virtual environment. Activate with source.venv bin/activate. This .venv folder is where UV is going to store all this information about different Python versions and different packages. So when I run, let's do a little clear here. So when I run UV run Python basic python.py, it jumps into this .venv folder and it finds all the stuff it's looking for. It's looking for the Python version and it's looking for all these packages. So for example, if I wanted to update this to make it a little bit more accurate, I would say UV environment, virtual environment, venv, and then I come back, I hit enter, and, depending on if I have the packages installed or not, it'll install the packages and then run my script. Now, these two environments are very different. Whenever we run a command with UV run, UV will automatically enter this environment over here and start running our code. When I run just Python 3.11, it's already inside of this global Python environment over here. However, we can also think of this a different way. We could think of there being some type of active Python environment. And if we don't specify one, it'll automatically go to the global Python environment or this, Python 3.11 or, whatever we have installed. However, we can actually set our active Python environment to be something called a virtual environment and have it be the same one that UV enters. The way that we can do that is we can do, when we do UVVENV, it creates that folder, which again, we've already created. We can activate what's called a virtual environment by running this command here, source.venv bin activate. And when I hit enter, depending on your shell or your terminal or your bash or ZSH, you might get a little parentheses bit here that says, hey, we're inside of a virtual environment called Python in Updraft Cyfrin Updraft. So now if I type which Python, I now will see this crazy long string in here telling us what the current active version of Python is. And now I can actually use the Python keyword. Or if I do which Python 3, I get the same thing. It's kind of in this crazy long area. But if I do which Python 3.11, I get this different kind of path, right? These two paths look pretty similar, just with one being Python, one being Python 3. But which Python 3.11 is this other path? And then what about which Python 3.13? Oh, I get that long path again. So what's going on here? Well, when we run this command, we activate what's called a virtual environment. And you can almost think of it as us pointing this active virtual environment to over here. We're saying, okay, the active Python environment is now this isolated, this fake Python environment over here. And we know that it's active because, again, we can see this little parentheses in here. And this active virtual environment actually comes with a whole bunch of extra keywords. It comes with Python 3. It allows us to just write Python, basic python.py, except if I do that, I get this module not found error, no module named boa. And this is because we first have to run UVSync. UVSync will install any and all packages that we set up with UVadd. When we run UVSync, it looks in our pyproject.toml at our dependencies section and goes, all of these Python packages that have been installed, we need to add to the .venv. Now, when I run this python basic.py, it'll work. Well, after a brief delay, it'll actually work exactly as we expect it to. So now we're inside of this virtual environment, right? We have this, we can look up python version. We can see a version in here. And this way, if you get annoyed with having to run UV run, Python basic, blah, 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 you can just activate the virtual environment with that source.venv bin activate, and then just run everything with Python. Now, to get out of this virtual environment, you can do a couple of things. Number one, you can trash the terminal and then pull it back up. We no longer see it's active. And for me, if I type which Python, I get Python not found. Now you might still have Python, but you'll probably no longer get the path to the venv. And again, we can reinitialize it with source.venv bin activate. Now we're back inside of it. The other way to get out of it is to write deactivate, and boom, now we're back outside of it. So UV is this tool that will allow us to create this virtual environment very easily, allow us to enter and exit the virtual environment, allow us to install tons and tons of packages and not have to worry about different Python versions, different dependencies, and a lot of other different issues that you're going to run into. UV also comes jam-packed with several other tools as well that we'll use throughout the duration of the course, and you'll learn more about how UV works, because in my opinion, it's the most modern framework for making absolutely sure that when you run code, when you run your projects, you never have to worry about the weird oddities of versionings having to be compatible or not. Okay, so we're pretty much done with the Python crash course and also teaching you about Python in Updraft. So at this point, you have learned a ton. Now, like I said, the way that we're going to be using Python is going to be a lot different than what a lot of other Python tutorials teach you how to do. I will tell you the equivalent commands to what other Python tutorials tell you, right? A lot of Python tutorials, for example, even the Titanoboa GitHub, it says, hey, install Titanoboa with pip install Titanoboa, but we installed it with UV add Titanoboa. The reason I'm setting you up very differently than what a lot of tutorials do is because I want to set you up for success. And at the beginning, there might be a little bit more context, but it's going to prevent you from running into weird bugs later on in your journey. Like I've said 100 times, AI is phenomenal at working you through these dependency issues and versioning issues and asking your AIs questions about, hey, I'm trying to do this, but I'm running into this issue. What's going on? AI is great at helping debug there. So to end off this section, let's do a quick recap of what we've learned with setting up our VS Code, working with Python in VS Code, UV, different Python versions, etc. So first off, we all installed Python into our Linux-like environments, and we can access and work with the Python version that we install with Python 3.11 - version. This is our globally available or systems or base version of Python that has its own set of packages associated with it. If we wanted to change to a different version of Python, we'd have to go onto the Python website. We'd have to download it. We'd have to maybe change some links on our VS Code to point to the right version of Python. And that's incredibly frustrating. So what we can do instead, we can just use UV to always manage our Python versions by UV run Python -- version. And it'll give us our pinned version of Python. If we want to work with a different version of Python, well, it's really easy. UV Python pin 3.12, and it'll now update our .python - version from 3.13 to 3.12. And I can do UV run Python -- version, and I can see we changed to 3.12.7. Additionally, UV will manage all of our packages in this thing called a virtual environment for us. So if we want to add a package, typically you'd install that package with pip install, or what we learned, which was Python -m pip install, and then your package name like Titanoboa. If I were to execute this right now, first of all, I'd have to say Python 3.11 -m pip install. This would install our package Titanoboa into our globally accessible Python environment. And as of right now, this is also our active Python environment. However, if we change Python versions, that package will not be available for this other Python version. So to add a package with UV, we would run UV add Titanoboa or whatever package that you want, and it'll add it to your project and update your pyproject.toml with that dependency or that package, so that no matter what version of Python that you're working with, you will always be able to very quickly and easily work with this package. When we do UV add, it installs it into this .venv folder, whereas when we do Python 3.11 -m pip install, it installs it into that kind of mysterious global Python environment. So, and we can even look in here, we can look at .venv, lib, we can kind of scroll down through all the different packages in here, and we can see this boa package in here, which gets installed when we do UV add Titanoboa. If we get sick of running UV run Python every single time, what we can do is we can activate the virtual environment that UV automatically sets it up for us. So we can just run UV venv, which will set up and create that virtual environment. Then we do source.venv bin activate. And now we have access to the Python keyword, Python -- version, without having to do Python 3-11, Python 3.11 - version. We can just simply use the Python keyword. We can also use the Python 3 keyword, and they both point to the exact same version. We can now also just run Python basic python.py. We can run all of our scripts. And if we get an error saying module not found, no module named boa, we would just run UV sync to make sure that we download all of the packages for the current version of Python that we're working with. We can run our command again. And now, after a brief delay to load everything up, everything works correctly. To get out of this, we would just do deactivate. And now for me, since I don't have a Python keyword in my global environment, if I type which Python, I get Python not found. If you type which Python, you might either get Python not found, or you'd get Python in a different place. If I were to run again, the source.venv bin activate, and now I type which Python, you can see that this Python command is pointing to my Python object inside of my .venv folder here. So this Python also is inside this .venv. So this .venv folder is containing all the information about the version of Python, the different versions of packages, etc., etc. If you have got this far in this course, well done. You have set yourself up to not fall into a lot of the issues that other Python developers fall into, and to be honest, the ones that I fell into when I was becoming a Python developer myself. You now have installed most of the tools that you're going to need to become a successful smart contract developer. And I'm so excited for you to get this far because you have some of the most modern tooling installed in your VS Code that's going to make you way faster of a developer than most of your peers out there. So at this point, you should give yourself a big pat on the back. And now is a great time to go take a break. Go grab a cup of coffee, maybe grab some ice cream, go to the gym, or whatever you want to do. Because as I always say, your brain absorbs information faster when you take breaks. Taking breaks is important. Congratulations for finishing the Python crash course and the Python in Updraft setup.